In this video, we are going to talk about how to create hex meshes. Now, today I'm going to be using MSC Apex 2024.1. This is a really good tool if you want to go ahead and create some hex meshes for finite element analysis. Now, here I've already gone ahead and imported the geometry. Now, to quickly create a hex mesh, here on the right, click on these meshing tools icon, click on the solid mesher, and for the mesh type, select this button that says 2.5D mesh. So then when your geometry is green, all you need to do is click the geometry and it will go ahead and create your hex mesh for you. Now, this is a very simple example. What happens when the geometry is more complicated? So here, let's go ahead and delete the old hex mesh and let's go ahead and modify this geometry just a little. So here, let's go ahead and open the push-pull tool. Let's go ahead and select one of these faces. Let's go ahead and extrude this by -20 millimeters. Let's go ahead and go back to the hex mesher and let's see if we can hex mesh this now. Now, here you can see that the geometry is now red, meaning I cannot mesh this geometry. Now, you might be asking yourself, what's happening here? Why am I having this problem? So let's go ahead and jump to maybe Notepad. Not Notepad, Paint. Let's go ahead and open the Paint app. So here on the left is going to be what worked before. And here, let's go ahead and describe what's going on here. So let's go ahead and mesh one of the faces with 2D elements. So let's go ahead and take this. And here you can see that one face is meshed with 2D elements. So one very key thing for successful hex mesh is the following. Can the face be extruded? If you can extrude the face, you can create a hex mesh. So here, let's go ahead and go to Notepad and let's look at one side of this geometry. One side of the geometry might look like this. So here, let's go ahead and roughly draw our geometry. And there's some holes in this geometry. Before, one side looked like this. I'll call it S1, side 1. But the other side also looked like that. So let's go ahead and draw something that looks close to that with some holes. And this was good for us because now the geometry can be extruded, or rather the mesh can be extruded to create our hexahedral mesh. And here, this bottom point will also be extruded like this. Now we have a problem for this new scenario. So our geometry looks like this. S1 still looks like a V with 3 holes. But now if you look at the other side, it no longer is a V. It looks slightly different because of this missing piece, if you will. The hex mesher doesn't know the following. Let's go ahead and draw the V here. But for this top right hand or top left hand corner, there's a problem. There's a missing piece, if you will. This is where there is a hole. So now there's a problem for the hex mesher. Here, it can extrude the elements from this point to that point. For this bottom point, it can extrude the elements from this point to this point. But for this top left-hand corner, where is it going to extrude the elements to? That's a big question mark for us. Alternatively, there's another face. So if we look at this right now, either this face could be extruded to this opposing face. So I'll go ahead and throw a 2D mesh on that also. So this face could be extruded to these top faces, if you will. But then the question is, what about this face? What does the extrusion look like there? So if I go back here and draw another scenario, the hex mesher doesn't have enough information regarding, okay, do you want me to extrude this face to this circular section? which obviously doesn't make sense? Or do you want this scenario where it tries to extrude this first face S1 to the second face S2? You can see it's because these two sides, if you will, they're no longer similar. So let me create a new notepad file. So let's create another example. Let's suppose we have maybe not that. Let's suppose we have a circle, if you will. And this is S1, and then this is S2. Perfect. So S1 and S2 have a similar shape. So you can hex mesh this side, and you can extrude to the other side, and it will also have a similar hex mesh. If S1 was maybe a star as an example, so let's go ahead and try and draw a star with just the mouse and the cursor. If the other side was identical, so here, let's go ahead and copy that. Since both sides are similar, you can create your hex mesh by extruding, if you will. So here, if we hex mesh this, perfect, we can extrude this mesh to the opposing face, and we would be able to get a hex mesh on the other side. So to show you this in Apex, let's go ahead and do this. Let's go ahead and delete the old mesh. Let's go ahead and extrude the other sides. Let's make this more complicated. So let's go ahead and select this face here. Let's select this face here with the shift key and hold it. And let's go ahead and move this negative 20 millimeters. So if we look at the hex meshing tool again, everything is red. One side of the face, which would be this side, is no longer similar to all the opposing faces here. So what we need to do is create what are called partitioning. So if we open the geometry tools and click the split tool, there is a partition option here. So what we're going to do is we're going to use this face that you see here. So let me see if I can. So this face is going to be used to partition this part of the geometry. So to partition, let's go ahead and make sure we've selected the surface option and the partition option here. Click the geometry, click the middle mouse button if it's not magenta or pink. Once you do that, hover over the geometry and select this face. Now, once you've selected that face and it turns golden, click the middle mouse button or the scroll wheel. And now I have a partition here. And I know it's a partition because there are actually dotted white lines here. If I go back to the hex mesher, you'll notice that this face here is similar to the opposing face. So if I go to the hex mesher, this partition or this cell can be hex meshed. Again, because one side is similar to the other side. So if I wanted to, I can go ahead and select that geometry and I get a hex mesh here. But now let's go ahead and do this for the other regions of the model. Let's go ahead and split or partition the geometry. So let's go ahead and select this big geometry. And let's go ahead and select maybe this face. Or first, let's go ahead and click the scroll wheel so it turns magenta. And let's go ahead and select that face and click the scroll wheel again. And now I get a second partition, if you will, and you can see that it's in dotted white lines. Let's go ahead and do this for this other region. So let's go ahead and, if you look on one side, there's no dotted line. Yeah, one side is circular, but you can see that the opposing side is not similar. So extrusion will fail. Let's go ahead and select this geometry, rotate this and select this face. And now you can see that I get a partition here on the other side. So when I go to the hex mesher, I now have these three circles, if you will. And on the opposing side, there are also three similar circles. If I go ahead and select this face, actually, let's go ahead and repeat what I just said a moment ago. This face has a similar face on the other side. this face has a similar side on the opposing side, and so on and so on. So now that I have all these different partitions where one side has a similar opposing side, so all these faces have a similar opposing side, when I go to the hex mesher, everything is green. I can now hex mesh this. And here is my close to final hex mesh, but there are a few problems with the hex mesh. If we look at this side, one of the elements is very distorted. And the reason that's happening is because a lot of the time, there is geometry that's so close to each other that it throws off the mesher. So here I've opened the vertex edge drag tool, and if I zoom in very closely, I get two edges that are very close to each other. These two vertices are very close to each other. So what do I do? I take one vertex and I simply drag and drop it to the adjacent vertex. And now if I go back to the hex mesher, you can see that that distorted element is no longer here. So if I zoom out a little, let me zoom in again. And let's go ahead and go back a few steps. So this is what that element looked like. It looked almost like a tetrahedral or pentahedral element. But this is what the mesh looks like after. So you can see I get a better shaped mesh, if you will. Now, for these other sides, I don't get a quite so friendly looking mesh. There's an option you can use in the hex mesher. It's this option called feature mesh for starting face. So let's go ahead and turn that off, and let's remesh this. And if I look here, actually, let me say this about this option. This will help you create good meshes around holes. So that's one option to turn on when you're creating your hex meshes. Another option you can use is the seed tool. So how does the seed tool work? Now what I do here is I count the number of elements, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here I'll type in 9. And then here for this outer edge, I'll go ahead and select that edge. And now it's forcing the mesher to use 9 elements along this edge. And when I do that, I now get a good mesh around the hole. Let's go ahead and repeat the process for this other edge. Let's go ahead and select this edge. And now I get a good looking mesh here for this other hole, if you will. Now, let me repeat what I mentioned a moment ago. Hex meshing works as long as one side has an equal side on the opposing side of the geometry. If this condition is met, perfect. You can go ahead and create your hex mesh, which involves meshing side 1, and then the hex mesher automatically extrudes the mesh to the opposing side. Now, I'll give you another scenario. Let's suppose that one side is a triangle, but then on the opposing side there's a circle. This cannot be hex mesh, because here if you try and mesh this triangle, how are you going to map this to a hole on the opposing side? So it's a problem for us. But here I give you an idea of how to create these cells or these partitions. So as long as you have these partitions, this is going to help you create these hexahedral meshes. Now, there are a few articles I want to leave you off with. This first one is called An Introduction to Hex Meshing for Finite Element Analysis with MSC Apex. This next article is from the documentation, actually. So if you Google MSC Apex online help, go ahead and jump to the hex meshing link, and here you'll get more information about how the hex mesher works. And then this other tool, or post rather. MSC Apex makes hexahedral meshes practical and cuts the entire workflow time in half. So this is an article that would be useful. Remember, as long as you have identical faces, you can create a hex mesh. So here, if this face has an opposing similar face, you can go ahead and create a hex mesh. Let me show you a few more examples. Here we have a bunch of other examples where you can create a hex mesh. So let's go ahead and put that here and here. So here are various other examples. Let me briefly talk about these examples. So here, this example, we'll go ahead and call it S1. Let me increase the thickness of this. So you know what? I don't even think that's right. Let's go ahead and move this here. So this could be side 1. But here, if you look at this opposing side, where is side 2? Here, what I would do is I would create a partition. Let's go ahead and create a partition here also. So this face, if you will, this is my S2, and then this other face is my S1. I can go and create a hex mesh here. Here for this other shape, this is maybe my S1, and here on the underside, let's go ahead and draw a dotted line for the underside. Maybe it looks something like that. So this is what my S1 and my S2 looks like. So this is hex meshable. So S1 and S2 are similar. Now this one's kind of a awkward one. If this is your S1, this cannot be used to extrude, because when you extrude, if you walk this way, there's like this gap or notch. This is the notch. That's a problem for us. So what you can do, actually, you can change the face. So here as an example, what if we make this the S1 rather? This is the first face here. So then we can go in this direction to this opposing face, S2. And now this will work. So let's go ahead and draw a checkbox here. So as long as you create these scenarios, these cells where side 1 is similar to side 2, then you can create the hex mesh. So that's pretty much the end of the video. Hopefully you found it informative in regards to creating a hex mesh. Just in case you do have a question for me, my email address is here on the screen. Feel free to contact me and I'll get back to you as soon as I can. So with that, I'll stop here. Thank you for watching.